Hey everybody, welcome back. This is another tutorial for assembly x86-64 Linux assembly, and today we're going to figure out how to actually print a string regardless of size to the terminal screen. So remember, if you haven't checked out my other assembly videos, go ahead and check them out. I have a playlist. And so what we're going to do is figure out how to write a subroutine that will print a string of any length. Whereas before, with the hello world, for example, we had to hardcode define the length of the string in order to print it. So I have some code here. And so basically what we're going to do is, starting off kind of same as before, we have a data section. We're going to put some strings in here. We have message 0, 1, and 2. We have assembly is fun. Now, what is the comma 10, comma 0? Well, I've added a comma 10, basically telling the program to insert a new line after printing that string. After the last character, after the last byte has been displayed to the screen, insert a new line, and then have a 0 at the end to just for us to know that the string is done. And so, yeah, same thing for these two. Okay, and so we've got a text section, we've got a global start subroutine. Okay, so now the first thing to do is we're going to move our message 0, our first message, into RAX, and we're going to call the subroutine print. Okay. So if we go down here, what we're going to do is we're going to push RAX. Basically, pushing RAX is going to save the value on the stack, which is the value of what's in RAX, which is our string. Okay, and then we're going to move into RBX 0. So why do we need to do this? Well, in order to print strings of an arbitrary length in assembly, we need to have an iterator, because we're going to print each byte, each character, one at a time. So we need to dynamically get the length of the string during runtime. And so this is kind of our iterator. So if you're familiar with any other programming languages, usually you would have, like you have a for loop, for example, and you have like int I equals 0, I++. That iterator, this is basically that. We're going to use RBX to do that. Okay, and so since assembly is very much, top to bottom, and there's no return value on print, we go straight into print loop. And what we're going to do is we're going to increment RAX and increment RBX. Okay, so with RAX, we're going to tell the program, go to the next available byte in the string. And so go to the next index in the string. It's important to note, not the actual data. This is going to the next index in the string. Okay, and then we're incrementing RBX, which is our, because since we've gone to the next index, that's another character, so we have to add one to the length. Now what we're going to do is we're going to move into CL, which I believe this is equivalent to RCX, but we're going to move into CL the data at the index of RAX. So these brackets basically mean fetch the data that is at RAX. If we just put RAX in here, it would just be a number, which wouldn't make sense. And so, yeah. So then, I lost my train of thought here, sorry. Yeah, so we're moving the data, that character, into CL. Okay. Now we're going to compare CL and see if it is equal to 0. Why do we do this? So, well, if it's equal to 0, we're at the end of the line. If it's not equal to 0, because remember we have a 0 at the end here. If it's not equal to 0, then we're not done with the string yet because we haven't reached the end. And then we're going to jump if not equal to, basically meaning JNE is a conditional jump where if the 0 flag is set to, let's see, so if it's set to 1, meaning that it is 0, it's going to go back up to print loop and keep going again and again. But if it's not equal to 0, 0, then this doesn't execute. I think, yeah, it's a little confusing, but all you need to know is that if this is 0, if this is 0, this is not going to execute. So, okay, that's going to continue going and count the length of the string, which will keep incrementing RBX. And then at the very end, when this is 0, this is not going to execute. So the 0 flag is 1. This is not going to execute. We're going to move into REX1, and this is similar to before. We know this. We're getting ready to print something. So we're saying basically we want standard output. Move into RDI, which is our file descriptor. We want to print something to the terminal screen. We move 1 into there. We're going to pop RSI. Remember, RSI is our buffer. So we're going to pop that off of the stack. And then we're going to move into RDX, which is our count, RBX, which is what we had just got done incrementing the length. And remember, RDX is our count. And so we already have the string that we want to print because it was pushed onto RAX. And so then we do a syscall and we return. Hopefully I got all of that right. For those of you who maybe know more about assembly or kind of caught something that didn't make sense, let me know. You know, I'm still learning as well. And so the best way to learn is to try to teach something. So that's essentially what this does. And then it's going to, it's going to return, go to the next one, do the same thing all the way down to here. And if you remember from before, when we move 16 to REX, we're essentially telling the program it's time to exit. We reset RDI and we syscall and it exits gracefully. So let me show you how this runs. So we're going to do NASM, x86-64, the assembly file, output, object file. Now we're going to link the object file with all the necessary libraries and output an elf file. And now we can execute that elf file and we get assembly is fun. And as you can see, after each message we have a new line and a new line and a new line right here. So there you go. Hopefully that made sense, and hopefully this helps.